Yeah.
All right, so we're going to finish up by looking at a little bit more with complex numbers written in polar. Okay, so just a reminder that complex numbers in polar look like this. It's r cosine theta plus I sine theta. Remember, to find theta, it's inverse tangent of y over x, except if you're in quadrants 2 or 3, you have to add something to it. Does anyone remember what you have to add? You have to add the 180 in degrees, or pi if you're in radians. And then to find r, that's using a theorem that we use in right triangles a lot. What theorem do we use to find r? The Pythagorean theorem. So the way you find r and theta, question?
No.
The way you find r and theta for complex numbers is exactly the way you find it for numbers that aren't complex. It's the same formula, the inverse tangent and the Pythagorean theorem. So, why do we even bother learning the polar form of complex numbers? It gives us a really fast way to do multiplication and division. So we learned how to multiply, and we did an example in the homework where you FOIL. Well, that's fine, but then you got to multiply first, outer, inner, last. If you get an I squared, you got to change it to -1. Combine like terms. There's a lot of stuff you have to do. In polar, you can multiply, and you don't have to do any of that. You can pretty much look at the problem and do it in your head. Right, so I'm going to show you an example. All right. So in an actual example, R1 and theta1, R2 and theta2, those would all be numbers. Kind of like, well, I got an example further down. I'll just show you down after. Okay. So we have two complex numbers. I'm just calling them Z1 and Z2. Each one of them has their own radius. Each one of them has their own angle. And again, you will be given what those are. Now, if we wanted to multiply them together, the old way in rectangular would be to FOIL it and do everything I said. Change I squared to -1s and combine like terms. It's not awful, but there's a faster way. So, to multiply two complex numbers in polar, you do two things. First, you have to find what your new radius is. Okay, so you've got to find that first. The new radius is just the product of the old ones. So you take R1, take R2, multiply them together, that's it. There's your new radius, that's half the problem. The other thing you have to find besides the new radius is the new what? Yep. You got to find the new angle. Each complex number had their own angle. So how do we find the new angle when we multiply them together? All you have to do is add the angles together. Right? So the new angle is the sum of the old ones. And it's the same thing here again. Bless you. So to multiply two complex numbers in polar, multiply the two radii, that's your first step, and then add the two angles. That's your second step. And you're done. Okay? Foiling, nothing like that at all. Okay, let's look at an example. So there's two complex numbers, both written in polar. The key that makes this faster is they're already in polar. If they weren't, okay, if they were in rectangular, then it might be more work to change them to polar and use the new formula I just showed you. Okay? All right, if I was given complex numbers and they weren't in polar, I would just multiply them not in polar. I would do all the foiling and get the answer. But if they are in polar, then I can do it real fast using this formula. Okay, so let's see what we got. Let's start with Z, so Z times W. Tristan, what's my radius for Z?
I'm not sure. I wasn't here Friday.
Oh, you weren't here Friday, so yeah, you missed how to write this. Elise?
3.
3. So my radius for Z is 3. What's my radius for W? Yep. 5. 3 times 5, that's the radius for Z times W, which is how long? 15. So halfway done. 15 cosine, and then I'm going to fill in an angle, plus I sine, and I'm going to fill in the same angle. So the rule says add the angles together. So what would my angle be in the final answer?
120.
120. And that's it. That's how you multiply two complex numbers in polar. Much faster than foiling and I-squareds and all the other stuff. But the only reason it was fast is because they were both in polar to start. Any questions on that one? All right, let's try this one. Okay, so same directions. Find Z times W. Now, you can call them whatever you want. You can call them Z1 and Z2 or Z and W. The point is, just take whatever the two things are and multiply them. Yeah, Joe? Can you just start with my radius? 5. Z has a radius of a half. W has a radius of 10. Half of 10 is 5. So I have 5 parentheses, cosine my angle, I sine my angle. Now I need my angle. Shelby?
Negative 15.
Yep. 15 plus negative 30 is negative 15. Negative 15. That's one way to write the answer. Before I'll put that in parentheses so it doesn't look like minus 15. It's negative 15. Any questions on how we got that? Okay. Now, what if they said to write it as a positive angle? How can you write negative 15 as a positive? The R doesn't change. That's going to stay as 5. Yeah. You could add 360. So what's negative 15 plus 360? Yeah, Tom? 345. That's a second way to write the answer that's also correct. Okay. Any questions on that way? Now, the only disadvantage to that way is the angle got a lot bigger. Okay, you had to add 360, which isn't that hard to do in your head, but you still had to add 360. You could have made a mistake doing that. And then the angle got a lot bigger. There's an easier way to get rid of those negative angles. And to see the easier way, I'm just going to show you a couple things and see if you notice a pattern. Let's take the cosine of negative 15. It doesn't matter what you get. I just want you to compare it to this. What's the difference?
Nothing.
Nothing. Let's just try another one. Let's try that cosine 78, cosine negative 78. What's the difference there? Nothing. So in other words, when you take the cosine of a negative angle, it doesn't matter. Negative angle, positive angle, you end up with the same answer. So really, we can just take this negative, we can just erase it. We can pretend it's not there, we don't need it. So I'm going to write 5 cosine 15. So I got rid of the negative there. Now I'm going to try the same thing with sine. Let's try sine of negative 15, sine of positive 15. What's the difference there? Shelby?
One's a negative, one's a positive.
Okay, one's a negative, one's a positive. How about the number itself?
Same.
Same. So the only difference is there's a negative in front. Okay, let's try another one. Sine of 28. Sine negative 28. Same pattern again? Yeah. So the only difference is there's a negative in front. So with sine, you can't just get rid of the negative and say it doesn't make a difference. It does. But you can take the negative and put it in front. Just like this. So you can take the negative and put it in front. So that's what I'm going to do here. This negative can go in front. So what it really becomes is a minus. So minus I sine 15. Okay, so any question on that? Okay, so negative with cosine, you just get rid of it. Negative with the sine, you can't get rid of it, but you can put it in front. And to me, I think that's an easier way to get rid of the negative, because then you don't even have to do arithmetic. You just erase one of the negatives and then move one in front. And that's it. Okay, so all of these are correct. It's just if the problem said get rid of the negative on the angle, you've got two ways to do it. Add 360 or the last trick I just showed you. Okay, so any questions on multiplying complex numbers in full? Okay, let's look at dividing. So it's the same setup. Okay, you've got two complex numbers. We're going to divide them in polar, and we've got to find the new radius and the new angle. How do you think we're going to find the new radius this time? What do you think we'll do with R1 and R2? It's very similar to the last formula. Well, Anna, what do you think? Yeah, so we're going to divide R1 and R2. That's going to give us my new radius. And what do you think I'm going to do to get my new angle? Pat?
Subtract.
Yeah, we're going to subtract. So it's kind of a similar formula to what we just did. So you divide your two radii and subtract your two angles. Now, this is the kind of problem that can lead to getting negative angles more often because you're subtracting. So I just showed you two ways to get around that. Okay, any questions on the formula? Okay, so we'll try a couple examples. If we get a negative angle, I would like to make sure we make it a positive angle. Okay, so let's see, we get z divided by w. Now, because it's subtracting the angles, does the order make a difference when you subtract? What do you think, Shelby?
Yes.
Yes. So we just want to make sure that theta 1 minus theta 2. Theta 1 is the one that was in the top. Theta 2 is the one that was in the bottom. Okay, so we've got 3 cosine 75 plus I sine 75. Any other complex number? 5 cosine 30 plus I sine 30. I think in the homework, the way they have it set up is they give you something just like that, and they ask you to do both. Take these and multiply them, and divide them. I'm just having you do one. So Joe, what's my radius going to be?
3/5.
3/5. Yep. 3/5 cosine, and Tyler, what's my angle going to be?
105.
Careful. When we're going to multiply them, it would be 105. But we're dividing them. So 45. Yep. So 45 plus I sine 45. And that's it. We're done. Okay, what we did right there, it took the place of having to find a conjugate, multiply top and bottom by it, FOIL it, change all the I squareds to -1s, all that stuff goes away. And that's all you have to do. Now, if the problem was set up and somebody gave it to me like this and said divide, I would probably divide them the old way, like we learned last week. I would just find the conjugate, because it's probably going to be more work to change this to polar and then change this to polar and then do it this way. These already were polar. That's why it was so fast. Questions on that? All right, let's try this one. Another z divided by w. This time with z, the radius is 10, the angle is 20. W, the radius is 1/2, the angle is 100. Okay, so let's start with our radius. Audrey, what's my radius going to be here? Careful, if W was a 2, then 10 divided by 2 would give me 5. But in this case, W is 1/2. So what's 10 divided by 1/2? $20, yeah, it's like it doubles it. So my radius is going to be 20. 10 divided by 1/2 is the same as 10 times 2. And now my angle. If it comes out negative, that's okay for now. We'll write it as a negative, and then we'll fix it. How about Mark? What's my angle going to be?
Your angle is going to be 80.
Careful. If Z and W were switched, like if it said to do this, then yes, I would agree with you. W divided by Z would have an angle of 80.
-80?
Yeah, this is -80. Okay, so let's just write it down. So cosine -80, I sine -80. Now, can somebody give me one way to fix that so I don't have a negative angle? There's two ways. Mac?
It'd be 20 and then it'd be cosine 240.
Yep. So cosine 240, I sine 240. So the way he did it, he added 360. That works fine. Or, other way, you don't have to do any arithmetic at all. Yep.
You get rid of the negative for cosine, and then the negative for sine just flips the plus sign to negative.
So the 20 stays in front. The negative with the cosine, it doesn't matter. The negative for the sine, it matters, but you just put it in front. All three answers are correct. If you put an I right here. Not correct. Any questions on that? Okay, so it's multiply, divide. Last thing we're going to look at is raising to a power. So let me raise something to a power the old way. Okay? And I'm not even going to make it that high of a power. Okay? I'm only going to cube something. Keep in mind, this could be a lot worse than cube. Could be to like the 9th power or the 20th power. And it would be a lot worse. But let's just take 2 plus 4i, and I'm going to cube it. Okay, and I'm gonna do this. Okay, cubing's not awful. It takes a little while, but it's still gonna take me less than probably 2 minutes. Maybe a little longer because I'm explaining. But what does 2 plus 4i cubed mean? Like if you were trying to explain this to someone that doesn't understand having a number higher than something, they don't know what exponents mean, how would you write it out for them? Yep.
2 plus 4i went like 3 times.
Yep, you'd write 2 plus 4i 3 times. And now, to do that out, we have to FOIL it, okay, twice. I'm going to start with the first two, and then I'll come back and do the last one after. So 2 times 2 gives me how much? 4. 2 times 4i? And then another 8i. So 8i plus 8i? 16i. Positive times positive is positive. 4 times 4? 16, and then the I times I? I squared. So that's going to give me 4 plus 16i. What's I squared again? It's negative 1 times 16 is negative 16. And 4 minus 16. Negative 12 plus 16i. So that's what you get when you FOIL the first two. And now we have one more on the end. And we have to do it one more time. And then we're done. So it's not awful, but it does take a little bit of time. Negative 12 times 2. Negative 24. Negative 12 times 4i. Negative 48i. 2 times 16i. 32i. And then 16 times 4. 64. And don't forget the I times I. I squared. Okay, and now once we combine like terms, we have our answer. So we've got 24. What's negative 48 plus 32? Yeah, negative 16i. And 64i squared is really what number? It's really negative 64. And now I have 24 minus 64. Sorry. Negative, it is negative 24. Yeah. So negative 24 and negative 64 is negative 88. Okay, and that's my answer. So not awful, but it took me a couple minutes, and then you make one mistake, like you forget to copy a negative, and then it's wrong. Now, that was only 2 plus 4i cubed. Imagine if it was like 2 plus 4i to the 12th. Now I'd have to do 2 plus 4i 12 times. And the chances of me making a mistake in there somewhere, probably pretty good. Okay, whether it's just a negative or adding or something. And then make it something like this. Now it's not even reasonable to try to do by hand that way. Okay. Well, there's a shortcut to doing this that it doesn't matter if you make this exponent a 12 or a 12,000. I can do it just as fast either way. Doesn't make a difference. The key is going to be how you write this. That's rectangular. What's the other way we can write it? Polar. So the whole key to doing this fast is doing it in polar. And this is going to be a case that if you wanted me to do this out, like literally like this, it would take me like days. Like I couldn't do that out. It's too big. But I can change this to polar in probably about 45 seconds, maybe less. I can change that to polar. And then I can plug it into the formula I'm about to show you in maybe another 30 seconds. So I would say in under a minute and a half, I can do this problem. Maybe even faster. All right. But the key is I have to use polar. And this formula is called de Moivre's theorem. That's how you say that. De Moivre's theorem. What's that? This is the last thing. Yeah. So on the test, what I'm going to do is I'm going to pick 2 out of 3 of the formulas we learned today. Okay? We learned how to multiply in polar. We learned how to divide in polar. And now we're learning how to raise to a power in polar. So I'd probably pick 2 out of 3 to put on a test. Probably wouldn't put all 3 because it just makes the test a little longer. I put every example of every type of thing we studied. The test would be like 40 or 50 questions. So this test is probably about, I think, 16, 17 questions. It's right around there. So here's the trick, or the Wahl's theorem. It's the formula you can use to raise a complex number to a power. The first thing you do is you take the radius and raise it to the power. So whatever the radius is, raise it to the power. And the second thing you have to do is you got to find your new angle. Well, to find your new angle, all you have to do is multiply the power times the original angle. That's it. Raise the radius to the power, angle times the power. And doing that would take the place of all that foiling I had to do. And it allows you to do problems you couldn't even do by hand the other way. Cubing was bad enough, even something to like the 6th or 7th power. You're still talking a good 5 to 10 minutes to do that out. And that's not even that big of a power. So we're going to do one that would be kind of it would be doable by hand, but if I had to multiply something out 8 times, it's going to take me a little bit of time to do it. But in polar, hardly any time at all. Okay. So my coordinate is already in polar. That's what's going to make this really fast. Already in polar. So DJ, what's my radius that I'm working with this time? 3. And what does the formula say to do? Take the radius and do what with it?
Multiply or add?
No, we're not going to multiply or add. What is it in the formula? What is it where you see
Add. Right? Or, oh wait. No, you're going to do the powers.
You're going to raise it to a power. Yeah. So he said the radius is 3. I'm going to raise it to a power. What power am I going to raise it to? 8. Yeah. So this is going to be 3 to the 8th power. That's my new radius. And those should be in degrees. Or it could have been 20 radians, but it's 20 degrees. And how do I find my new angle? Yeah.
Multiply 20 by 8.
Multiply 20 times 8. So my new angle is 160. And that's it. You're done. So I was able to raise something to the 8th power.
So you don't
Very fast.
do about 3.
I mean, 3 to the 8th, you could leave it like that. It's not huge. I mean, 3 to the 8th, it's not like it's in the billions or trillions.
6,561.
So yeah, it's kind of a big number, but it's probably big enough that they wouldn't have you do it out. If it comes out to like under 100, they'd probably have you do it out. But when it starts to get up into the thousands or the millions, you can just leave it as 3 to the 8th. Now, one thing that could have happened is, let's say we raise this to the 50th power. Well, 3 to the 50th, you definitely leave it. That'd be huge. But your angle would have been 20 times 50. That's a big angle. That's a 1,000-degree angle. What can you subtract to make an angle smaller if you have to? Yeah?
360.
Yeah. So, if you get an angle that comes out bigger than 360, you can subtract 360, and you can do it again, and it would actually be 2. So if the angle comes out too big, just subtract 360. Okay, any questions on that? So multiplying in polar, dividing in polar, powers in polar. Okay. All right. So if this is what we'll take a look at. We've got about 35 minutes. So it's five questions. 33, 35, 37. And then 41 and 42, they give different directions in the book. I'm just telling you to leave it in polar. Okay, just leave the answer in polar. And I think 33 through 37 each have two parts. They're going to give you two things to multiply, and then they'll take those two things and divide them. Okay, so when you finish that, just show me. I'll check it off. And then as far as tomorrow, again, I'll let you know very soon my plans.